Tornadoes are intense, rapidly rotating columns of air that extend from a thunderstorm to the ground. Their formation is a complex process involving several atmospheric conditions. Here's a detailed explanation of how tornadoes form, the conditions required, and the general timeline of their development. Number 1. Basic ingredients for tornado formation. Warm, moist air. Tornadoes often form in environments where warm, moist air from the Gulf of Mexico is present at lower levels of the atmosphere. This air is typically unstable, meaning it can rise quickly when disturbed. Cold, dry air. Above the warm, moist air, there is often a layer of cold, dry air. This difference in air temperature and moisture can create strong instability. Wind shear. This is the change in wind speed and direction with altitude. Wind shear is crucial for the development of rotation within the storm. When wind at the surface blows from one direction and wind at higher altitudes blows from another, it can cause a horizontal spinning effect in the atmosphere. Lift. A lifting mechanism like a cold front or a warm front forces the warm, moist air to rise. As the air rises, it cools, and if it cools to its dew point, clouds and thunderstorms can form. Number 2, the process of tornado formation. Supercell thunderstorm development. Tornadoes most commonly form from supercell thunderstorms. A supercell is a large, rotating thunderstorm characterized by a deep, persistent updraft known as a mesocyclone. The wind shear tilts the rotating air from horizontal to vertical, which can help the mesocyclone to form. Rotation intensification. As the updraft intensifies within the storm, it stretches the rotating air column vertically, tightening it and causing the rotation to speed up, much like a figure skater pulling in their arms to spin faster. This is a critical step in the formation of a tornado. Tornadogenesis. If conditions are right, the mesocyclone can extend downward toward the ground. This stage involves the formation of a funnel cloud which may or may not reach the ground. If it does reach the ground, it becomes a tornado. The time it takes for a tornado to form can vary. Once a supercell is formed, a tornado can develop within minutes to an hour. The process of rotation intensifying within a storm can happen rapidly, especially if the wind shear and instability are strong. The lifespan of a tornado varies greatly. Some tornadoes last only a few minutes, while others can persist for an hour or more. The average tornado lasts about 10 to 20 minutes. However, in rare cases, tornadoes can last several hours, traveling over long distances. Tornadoes generally weaken and dissipate as the parent storm loses its intensity. The updraft weakens or the inflow of warm, moist air is cut off. Sometimes, tornadoes dissipate after encountering a colder air mass or when the storm moves into a less favorable environment. As the tornado weakens, it may go through a rope stage where it becomes narrower and more elongated before finally dissipating. Tornado formation requires specific atmospheric conditions, including warm, moist air cold, dry air wind shear, and a lifting mechanism. The process begins with the development of a supercell thunderstorm, where a rotating updraft known as a mesocyclone forms. The tornado itself can form within minutes to an hour after the supercell is established and typically lasts for 10 to 20 minutes, though some can last longer. Tornadoes dissipate as the storm loses its energy or moves into a less favorable environment. Tornadoes are among the most violent and unpredictable weather phenomena, and while meteorologists have a good understanding of the general process, predicting the exact timing and location of tornado formation remains a challenge.